everyone. My name is Michael Shnitman. I am Director of Software Development at RightSoft. RightSoft now is a division of MiTek industry companies, so I'll tell more about that. And I'm going to tell you a little bit about the RightSoft history and then show you some demo how to use our IntelliCAD-based software, which is one of the many software packages we have to do the HVC design. So about RightSoft, our market focus is HVC system design and energy. HVC is abbreviation for heating, ventilation, and air conditioning. So geography of our customers is primary North America. It's United States, Canada, and a little bit in Mexico. But there are some users in other countries all over the world, probably 2%, not in North America. So we are really expert in HVAC. The company was founded 33 years ago by Bill Wright. Many of you know him. And our office location for most employees is Lexington, Massachusetts in United States. Lexington is a suburb of Boston. In 2017, our company was acquired by MiTek, which is also in turn the division of Berkshire Hathaway company. So now we are grandchildren of Warren Buffett company. So about MiTek, our parent company, it is a global supplier of software, engineering products and services and manufacturing equipment for the building industry. So it comprised of more than 40 companies operating in nearly 100 countries. One of these 40 is RightSoft now. More than 7,000 employees worldwide, and headquarters of MiTek are in Chesterfield, Missouri, United States. And MiTek became a Berkshire Hathaway company in 2001. Now about our RightSoft team. So it's basically 30 people, which mostly located in the United States. Also, we have some developers and IT personnel in Russia. There are some designers in India and developers in Canada. By the way, we have 5 proprietary developers from IntelliCAD. That's our Russian team. And 2 of them are here today, Sergey Spirin and Evgeny Guryanov. So those developers not necessarily work only in IntelliCAD-based software. They work on all other software, and they basically learn all our technology pretty quickly and become really productive members of our team. So we sell our software, have a licensing system that we either sell perpetual license or subscription licenses, depending on the product, and some of them can get both, depending on user choice. Primary customers are HVAC contractors and engineers. We have deep industry links because we've been in business a long time. So this is some of the logos of companies that either provide their manufacturing data to our software, and those are mostly HVAC equipment manufacturers. So if any of you have air conditioner system or heating system, the equipment there probably one of those. And also we provide custom version of our software for those manufacturers with their logos and even sometimes specific calculations and equipment data, and they then promote that software to their dealers. Technical partners. So there are, well, my friends at ACA. This ACA, it's actually pronounced ACCA, and that's not your company. That's so don't worry about that. It's Air Conditioner Contractors of America abbreviation, and this is an organization who develop calculation methods and standards that all HVAC design for residential buildings should obey, and we were exclusive technical software partner for them for 18 years. ASHRAE is another organization which is mostly target engineers and commercial designs, and their methods are basically accepted not just in the United States but in the entire world. I guess that it's very famous organization, and their standards are accepted in other countries. ASHRAE is Canadian organization similar to ACCA, and there are other organizations related to energy, radiant heated, etc., which we all have method implemented based on their standard. So our software domain, design of heating and cooling systems, energy estimate, and for the last 3 or 4 years we start actually providing design services to builder. In other words, we now have a design team in RightSoft who actually do engineering design using our software, and I think they have done around 20,000 individual designs for that time, and that actually works really well because they know we're expert and we know how to use our software, and we also even make some fine-tuning to make them software work even better for them. A little bit history about RightSoft and MiTek. It was founded in 1986, and the first product was load calculation DOS-based program. Then we added a couple of modules during end of 80s and beginning of 90s, all in DOS, for DOS operating system. Most of you don't remember what it is, but it was a long time ago. And then we converted it to Windows in 94. Then in 98, we integrated all modules into single program because it's all sort of relate to each other, and instead of transferring file between modules, now it's like one package that works together, which improve the flow for users. In 2000, we introduced our RightDraw, which is, we developed drawing engines. It's a 2D and 2D engine, even though it performs calculations in 3D, which actually not just draw it, but also calculate at the same time. So that become the primary method to describe the building instead of entering all of these details in various worksheets, which was really a good, I think nobody did, at least in our industry. Either they have the drawing programs that just draw, or calculators that just you type in sort of spreadsheet like forms and then it calculate. That was when it all worked together. And in 2005, we applied for Autodesk ADM subscription, and they reject us 3 times. And we couldn't figure out why, because we're a small company. And then finally they say that we consider you basically major competitive, because I guess they wanted to do something on their own to make HVAC design as a vertical application in AutoCAD. So we were flattered on one hand because we are like 25 people, and all of a sudden we are competitors to them. So we then joined ITC in 2008 and basically started developing add-on for ITC for IntelliCAD. And then all of a sudden in 2015, Autodesk contacted us and say, well, why don't you guys join us? And we asked, why? What happened? I guess they couldn't do this HVAC modules that work, I guess. So then they decided it's better invite us back. We already were on the way doing IntelliCAD, so we basically rearrange our code that we sort of have a more or less common structure to handle both IRX and ARX. And so now we're developing all in parallel and maintaining these applications. So in 2018, we finally released RightCAD, which is our IntelliCAD-based solution. It was very successful. People really like it because it gives them the 3D engine, CAD-like platform, because a lot of them have DWG files as a primary output, and before they need to convert it back and forth with other program, which is RightSuite Universal, to do the calculations. They put it back. Now it's all work in one program. So they're very happy. And in 2019, we released AutoCAD plugin for various, which is similar to IntelliCAD plugin, but works for AutoCAD. So our products, so RightSuite Universal family, which include our standalone RightSuite Universal, then AutoCAD plugin and IntelliCAD plugin, it's also part of this family because they all share 90% of the code. We also have web-based application which do simplified version of our main applications. This is just a web app that people log in and do some simple, more simple but still very useful calculation and produce proposal, select equipment, and we have probably 5,000 or 10,000 customers that use in the web application. Some of them use both. When they begin with a web application to present it to customer, get proposal and win the job, and then they go to office and transfer those files that they did to main applications. They do detailed design. Those applications also work on the phone. So technical strategy. Basically, we have a sort of the big circle, it's HVAC engine. It's 22 various modules related to HVAC, energy, quotation. Then there is a level of common code, which is sort of interface. There is an abstract geometric entities that doesn't depend on particular drawing engine, but represent HVAC smart objects and know how to, with both geometric and not geometric properties, and that they can transfer information to the engine, calculate, get back results. So all the brains we try to put either to the big circle, or most of the brains as much as we can, or this little sort of half circle. And then there is interfaces to various drawing engine or UI, we call it. So CAD is IntelliCAD and AutoCAD. Then our RightDraw is that drawing tool that is used in our RightSuite Universal. The mobile app, since even though it's simpler, you still need to do the calculations properly. So it's just a simpler UI that fit to the same our program, which runs as a home server on one of the internet servers, and it basically just calculate the same way and then return result to that UI. Others is just potential other products, could be SketchUp, Revit, or something else. So that framework should work really well. And the goal of it to keep all of this complicated code and brains in one place. So another way, if you implement another calculation methods or anything else, it's only in one place and all others just interface to that. I guess the disadvantage of it is that if you add something and break something, it basically break all other programs, right? Because it's in one place. And since we don't make any bugs, it's not a problem for us. So just kidding. But yeah, we managed to keep it pretty reliable, this system. RightSuite Universal, this is all the modules, and it basically could be broken down into residential and commercial modules. So I'm not going to go through all of them, but it's a load calculation, duct design, radiant heating, operating cost, proposal, energy simulation for residential, and for commercial, similar, and they use different methods depending on the geography we target of our customers. Customer base, 90% of users are US and Canada. That's actually 15,000 separate companies who bought our software, and some of them buy more than one license seat. So I think we all together we have around 40,000 active license seats. And all major manufacturers in the United States, basically, not all, but the data is for all, but maybe half of them have customized version with their kind of branding that they sell. And it is still our software, it's just, branding different. Here is the North America map. And then if we click here, this is where our customers are in North America, the red color dots. Customer profile, even though we have a lot of companies as our customers, but most of them, 80%, are 2 to 20 employees. So the small companies who need to do the HVAC calculations in some sort, and then they actually go and build that HVAC system for residential houses. So they are not really technically strong. Most of them are not engineers, but just people who know how to build the HVAC, but not really into technical calculations, etc. They're very independent. They have fractured attention because they're always busy with other things. And they need to be alive, they need to sell more and more, so they have very strong sales focus. And so they don't have time to learn the software for more than 2 days. And if they can't get it, they would give up. And it also needs to be easy and fast to use. So typical flows, they describe the building using right drawing, some sort of drawing, and then select central equipment, layout and size ducts, radiant piping, depending what they're doing for distribution, produce bill of material, a quote for the job, and then at the end they need construction drawings to build this, and also a bunch of reports, calculations, and permit reports that very often in a lot of states, in Canada I think it's everywhere, in the United States, most of the states require supply the special permit reports and calculation before you can build anything. So they need that too, otherwise nobody let them build this design. So what is RightCAD? It's a CAD interpretation of RightSuite Universal. So we use the same intelligent HVAC objects that know how to draw themselves, connect to each other, and calculate. So we have a UI customized for HVAC workflow, and we think it's easy to learn and use. So we have, it's not really 2 workspaces. We have a special workspace, which is HVAC, which only shows you what you need to do HVAC design. And then if you want to do other generic things, you can switch to regular IntelliCAD or AutoCAD workspaces. So we have custom ribbons. Our layer tool, we build something on the top of IntelliCAD or AutoCAD layers because we need at least 2 levels of layers and easy to hide and hide various sections. Custom entities, obviously, rooms, windows, doors, ducts. Those are dedicated to HVAC property. We don't really need to draw it in the same level of details like architectural, but it needs to be seen that it's a window, door, or roof, or wall. It does enough because the drawing of each of these entities define the geometry and also the not geometric properties needed to calculation. We do a lot of automation in our software to automatically lay out things, calculate, and so to make it as simple as possible for users to produce the correct designs. So I'm going to show you a little bit what our RightCAD software can do. So I just started RightCAD, and this is basically IntelliCAD, but also it has our calculation windows. Usually it's much better to do it on 2 monitors because then you can put it full-blown worksheets and see how things change. But also I make the default as our own ribbon, which is like 3 panes: the drawing, the calculation worksheet and set up. So basically you need to draw your building, and then it would calculate what it needs to, and then allow you to design your duct system, produce bill of materials, and print the report. If you have architectural drawing or DWG floor plan, you can just open it up and then trace it with our entities to do the calculation. Even if you have a PDF, the same thing. Or if you don't have anything, that's okay too. You can just draw it from scratch, and that's what I'm gonna do. So I'll start with the room and start drawing. Before I do that, maybe I'll show you something. So now if I go to, so right now, since I didn't draw anything, I have 0 heating and cooling load. This is like a summary. So I'm gonna just start drawing, and just to show that calculations are live, I keep drawing, and then things change as I drew it. Yeah, it knows interior and exterior walls, so if I don't do it right, then it shows that the wall is. So now it's the thin lines represent that it's interior walls. Somehow my mouse here jumping can get to the corner. So if the room is not rectangular, you can make it any shape pretty easily. We have this custom command edit points that you just move it to any shape, or you can use line by line to draw the same room. So as I draw things, my load keep increasing. So now I'm gonna start adding windows. So you don't need to be precise, you just put it and it snaps it to the wall. You can copy and then make it the same. If they all the same, then you can just keep putting it, and then when you release it will basically snap to the walls. And okay, so now I get the windows. I'll put the door in. Each of these objects have its own properties, geometric, like door openings, and also, most importantly, calculation properties like U values that you can get to any object, and then it has all of these complicated rules, triple pane, you pick your construction. There are defaults, that's what gets applied when you drop your new object, but you can individually change one or more later. So I'm gonna also, for example, there are some buildings with, let's say, vaulted ceilings. So we have this sort of most typical roofs, and you can change some parameters. I'm just gonna put like, for mansard, I'll put that, so it'll put the things, and I can, why do I need the roof? Because I need to know if there is no ceiling between second floor, the last floor, and the roof. It's just a vaulted ceiling, that shape, so it needs to be included in calculation, and the volume and the surface area. So I also can put the dormer here, and let's say this, and then, yeah, so that's the dormer, and I'll put the window in. Okay, so that's my dormer, and let's say I'll copy this dormer in here as well. I need to rotate it because it's facing the wrong direction, so it shows you that it doesn't work, this light line. So I'll just say, okay, so now it works, and then I'll drop a couple of skylights, which windows inside the roof. Well, anyway, as I'm doing all of this, this thing keep changing. So now I have heating and cooling load calculated for each room and for the total, and it's all essentially in 3D. So so that's the house, and it representative enough in 3D so you can see if you did everything correctly. And if you have your architectural drawing in 3D, you probably when you print it, you would hide our layers, our own room and windows and doors layer, so it just shows only the architectural entity. So now once I get the load, here is our layer 3. So it actually already calculated the ducts, how much CFM you need, how much CFM is how much airflow you need in each duct. So all you need to do is now, let me just hide this. You need to position your register. I'm going to also hide ceiling. I don't really need it. So now I have the register, so I can position. This is my unit, and I'm just going to put it here. And I'm going to add a couple of return registers. And let's say I can either connect it manually, or I can let the program produce typical duct layout. Say x-axis plenum. I can still move things around and it would regenerate. So this is actually, I basically completed my duct design, because see it has all the sizes. I can show it in 2D, two-line mode, you know, in plan, or I can look at it in 3D. Let me just switch to that mode. And so you can see that this is produce the duct system, which is all the fittings, all the connections are not just calculated, but displayed, and you can see like interferences with the wall, so you can pick up your duct to go around, etc. Also, if we go back to this, and I'm going to go to proposal. Oh, before I do that, I also want to show you something. In addition to the duct designs, a really cool feature, sometimes people do heating using the ducts, but very popular in cold climate, put the piping in the floor, which makes it so we have this module radiant heating. So so it lay out the pipes in the room, and those are hot pipes, but so basically the whole floor become as a very warm floor, and that's very good for comfort, but you still need to lay it out, and there are different properties, like you can change the spacing to different, there are all of these rules about how they need to lay out. So all of this is built in our program, and if you have a kitchen cabinet, you don't want to go pipes go underneath, it will go around the obstacle automatically and recalculate, obviously, and I'm just going to connect it to the manifold. And just to show that and that puts it on different layers, so that's why we have our layer 3, so you can easily hide things, so they don't, like for example, radiant floor notation just give you all of these calculations, flow and temperatures automatically, because it knows the heating load needed for this room to be accommodated, and geometry and piping location and diameters, that's all allow it to calculate everything. And now as I am doing things, now I go to bill of materials. So it produces the list of materials for radiant heating, and then for ducts, whatever I draw, since it calculated all their properties, and we supply some maps to real manufacturing parts. So then if you select one of these manufacturers, then you actually produce the correct bill of materials with correct part numbers. If you using somebody else, there is a generic set of materials that you can basically, there is a mapping editor that you can map generic parts to the manufacturer or multiple parts that you are using, you meaning the user of the program, and then it's going to be stored globally in the database, and your parts will be then populated, program will populate with the actual parts you use. So just to show you that it's all live, right, I'm just going to go, let's say, to... So right now, after I did all of this, the cost of my system, let me see, where is the total cost? Overall total, now it says $18,000, right? So I'm just gonna, let's say, go and delete the skylight. So all of a sudden the price changed, and it took less than maybe 1/3 of the second. But let's think for a while what really happened. When I delete this skylight, that means that the load, heating and cooling load for this room changed. So I need to recalculate that, but not only that room, but all other rooms, because there is infiltration distribution change. So basically it recalculated all low heating and cooling loads. After it did that, it needed to redesign your duct system, because now airflows are completely changed, and one branch was eliminated because that room doesn't need to register, it needs one. So it did all of this and balance each run. It's an iterative calculation to make sure that it picks the smallest diameters. After it did that, it basically counted all, once it knows the sizes, and it did something similar for radiant heating pipes, and then it counted all the fittings, all the ducts with the new lengths, and then look up in the database for its pricing, and then it gives you the different price, right? So I was just talking for a minute, and that's what it did actually. So if I Control Z, it now coming back. I just undo my deletion, so it's coming back to the previous price. So that allows people actually pretty quickly manipulate and see what happened. Like maybe, I mean, I have this 18,000, maybe if I move this register somewhere else, it's gonna be different price. So plus very often our competitive programs, they have a very sort of strict way to do things. And this is a logical way, of course. So you draw your building, define your surfaces and calculate the load, then you select equipment, then you do the ducts, and then you produce the bill of materials. But then you've done, and then you realize that, okay, well, I forgot this skylight, I need to delete, or that window was actually not this type, but different. So very often that means that when you change it, you actually need to start over, right? Because everything changed. The window, it's at the beginning and you're at the end. So very often that requires redoing it again. But in our program, we made it that always any change, we try to retain whatever was there. And if it's still possible to retain, we keep it, like duct connection. If it's not, then we have to do something like reconnect or delete. So this all makes it harder to program, obviously, because it's not sort of logical way, but that makes it's very easy to use because users do whatever they feel like, and it always gives them something which is correct for the stage of the drawings they did. So I think that concludes my presentation of the RightCAD software, and if you guys have any questions, please ask. Thank you.